All right, and for the last page, okay, just 3 more. Almost at that home stretch. So I have a root here, and I also have a fraction with exponents involved. So when you're taking the derivative, I highly recommend just break it down as much as possible and make it something that you've seen before. Okay, so basically I'm going to manipulate this so it looks a little bit easier for me to deal with. So because I have a root here, okay, I'm going to have a fractional exponent. So this guy is going to turn into 1 over x. Well, you can barely see that. Let me use a pen while I'm writing over this white out. Okay. So 1 over x to the 35th power. Okay. And then the power for this, because of the root, is 1/2. Okay. Now I can simplify this even further. And again, this is 35. I can simplify this even further because I have this exponent. So the whole thing is going to be to the 1/2. However, the inside is going to change just a little bit. So to bring this guy up, we just basically make that exponent negative. So x to the negative 35. Okay, negative 35 is my exponent here. So now I can simplify this just a wee bit more, okay? And so remember, when we have a power to a power, we multiply. So I'm going to end up with x to the negative 35 over 2. Okay? So really, I'm taking the derivative of x to the negative 35 over 2, which is just x to some power, which is something that I've seen before. And so I can definitely do this guy a lot easier than I could this one. Okay? So if you need to break things down as much as you can, then that's what you should do, okay? So the derivative. So again, we take the derivative, the exponent's going to fly over in front, so negative 35 over 2. And then you take 1 from this. So negative, I'm going to do a little side work so you can kind of see where these numbers are coming from. So when I take the derivative, or I subtract 1 from this, I have negative 35 over 2. Okay. And another way we can write 1 is we can write it as a fraction. So anytime we have the same number over itself, okay, that's just the same thing as 1. So really what I'm doing by subtracting from 1 is just making this a way that you can subtract the fractions a lot easier. And so now I can just subtract across. So negative 35 minus 2 is going to give me negative 37 over 2 as the power. Okay, so this is negative 37 over 2. Okay. So now what I want to do is just kind of break this down and simplify it as much as possible, because I don't really like having this negative for the fraction. So I want to try to see if I can get rid of those things. So to work with this negative, again, negative exponents mean that it's going to go to the bottom of a fraction. So we're going to have negative 35 over 2, because that 2 is down here, 2x to the 37 over 2 power. Okay, so to get rid of this negative, we put this on the bottom of the fraction. Okay, we're not doing anything with the top. We're also not messing with this 2. Okay, so to get rid of this fractional exponent, what we're going to do is the number at the bottom, again, tells us what our root is to. So because it's 2, it's a square root, so I don't need to put any number there. And then this top number tells me what power it's going to be while it's in the square root. So x is going to be to that 37th power. And so that ends up being my answer. Okay. All right. Almost there. So we have a couple rules going on here. We have our number, or our number to an exponent. We have a constant, and then we have our e. So we're going to do the 3 different things for this guy. Okay. So because we have addition and subtraction, we are going to look at these each individually. So I'm going to do this guy in pencil. So 6 to the x. So whenever I have a number to a power that's a variable, I'm going to use the natural log rule, okay? So d over dx. So my derivative is going to be the natural log of 6 to the 6x power. Okay, so that's the first guy. The second guy, okay, the derivative of a constant is just 0. Okay, and then the derivative of the last one is going to be plus. So again, keep what you have when you have an e as your exponent. I'm sorry, an e as your number in your function. Okay, so we keep it and then we take the derivative of the top. So chain on the derivative of the top. So 4x, so remember 1 is basically my exponent. So I bring that down, I get 4. So I'm going to have 4. And then 1 minus 1 is 0, which is 0. So we just have 4. So we don't need to clean this up. This guy's going to go away. And then to clean this up, we just do 4 times 4. So 16e to the x. I'm sorry, 4x. And so now my final answer ends up being the natural log of 6 times 6x plus that 16e to the 4x. And then for the final one, okay, this one is the one that requires a little bit of work, a couple steps involved, okay? So find the equation of the tangent line to the graph f of x, which equals x squared minus 2 over x plus 1 at the point at which x equals 0. So step 1, okay, find your point. So we want to find the point that we are focusing on here, okay? So the point that we're going to focus on has an x of 0. So in order to find the actual point, we need to sub it into the actual function and see what the y value is so we have a coordinate, okay? So we'll have 0 squared plus 2, minus 2, divided by 0 plus 1. So I know 0 squared is just 0, so we're going to have negative 2. 0 plus 1 is just 1. And so negative 2 ends up being that y value. So the point of interest here is 0, negative 2. Okay, so that's step 1, finding your point. Step 2 is finding your derivative. Okay, so we want to find the derivative of the function. Because we have a fraction here, we are going to use the quotient rule. Now, if you wanted to use the product rule, you could. You would just basically put this to the negative 1 power, and you have to do the chain rule 1 extra time. But again, it's up to you, whatever you're most comfortable with. So in order to do the derivative, okay, we take the derivative of the top. Okay, so the 2 comes down, so we just have 2x. Again, a constant is just 0 times the bottom, so x plus 1. Minus the derivative of the bottom. So really this is a 1x, so we're just going to have 1 times the top, so x squared minus 2. And that's going to be divided by the bottom squared, so x plus 1 squared. Okay. And then we can clean this up a little bit, so just distributing this out, so 2x times x is 2x squared. 2x times 1 is plus 2x. Anything times 1 is just itself. And then same thing here. So we're going to actually divvy out this minus or negative 1 to both of these. So we're going to have, so negative 1 times x squared is negative x squared. Negative 1 times negative 2 gives me a positive 2. And then we're going to keep the bottom as is. And then just combine like terms. So 2x, so this guy and this guy are the only ones that are alike. So 2x squared minus x squared gives me just x squared. And then put the rest on. Okay, so we end up with x squared plus 2x plus 2 all over the quantity of x plus 1 squared. Okay, so that ends up being my full derivative. So now that we've found our derivative, step 3 is going to be finding your slope. Find slope. Remember, we denote that with an m in our linear equations. So to do such, we're going to sub in x equals 0. Okay, so we're going to use our derivative. Okay, right here, I'll sub in x equals 0 in derivative. Okay, and again, we denoted that as d over dx. Okay, so you know where all these numbers are coming from, or parts. Okay, so we have our derivative of 0, and that's going to be 0 squared plus 2 times 0 plus 2 over 0 plus 1 squared. And so 0 squared is 0. Anything times 0 is 0. So I just end up with a 2 here. And then 0 plus 1 is just 1. So 1 squared is 1. So 2. So that means that my slope is 2. So the last and final step is to plug in slope, use your point, and find equation. Okay, so we're going to plug in the slope that we found, use the point that we denoted in the beginning. Oh, can't even see that. Use the point that we used in the beginning, or that we found in the beginning, actually. And basically, we can use 2 different methods to do this to get our equation. Okay, and I've showed you these before, but I'll show you both again. So we have slope intercept, which is that y equals b plus mx. Okay, so we have this way, or if you like to use point slope, that is going to be y minus the y of the point, and the slope times x minus the x of the point that we used in the beginning. Okay, so if I do the slope intercept way, I'm plugging in the point for x and y, and then solving for b. So I'm going to have negative 2 equals b plus my slope of 2 times my x, which is 0. Anything times 0 is 0, so boop, that goes away, and negative 2 equals b. So with that said, I can rewrite my equation as y equals negative 2 plus my slope times x. Again, if you want to rewrite this, you can as y equals 2x minus 2. You'll end up getting this answer for this guy, but they mean the exact same thing. So these end up being my slopes if I use slope-intercept form. If I use point-slope form, I have y minus the y-coordinate of my point, which is negative 2. And that's going to equal my slope times x minus the x of my point, which is 0. So this guy kind of goes away. This becomes addition. So when I have a minus and a negative, it just ends up being addition. So I have y plus 2 equals 2x. And then subtract the 2 from both sides. And you get y equals 2x minus 2 as your final answer. Please remember that the test, again, is only on Chapter 3. Okay, it is on Wiley. I will leave it open until 4:30 on Tuesday. It will also be timed. So please make sure that you take it at least 75 minutes before 4:30. Okay, so that means you would need to take it, what's that, I would say don't take it any later than 3 o'clock. Okay, so again, time test, same as last time. However, it's only on Chapter 3. And I believe it's less than 20 questions, so it's not too many, and it's basically on everything that we just did of finding the derivative. Okay, so make sure you study up your notes. Email me. I will check my email daily from here until Tuesday. Okay, so make sure that you stay on top of stuff, and I will be back with you guys shortly. Just make sure we are checking announcements too. Okay, all right, have a good one, guys.